Welcome to AI Frontiers Podcast, Robotics Research Digest. This episode explores recent breakthroughs in computer science robotics, focusing on locomotion, manipulation, and safety. Insights are drawn from 19 seminal research papers published in May 2025, showcasing how artificial intelligence is advancing autonomous systems. Computer science robotics represents an interdisciplinary field combining mechanical engineering, artificial intelligence, and computer vision. These autonomous systems find applications in industrial automation, healthcare assistance, and environmental exploration. Key challenges include operating in dynamic environments while making real-time decisions with limited computational resources. The major research theme involves developing robust locomotion for challenging terrains. The work by Plozza and colleagues demonstrates how reinforcement learning controllers enable small quadrupedal robots to navigate uneven ground. Their system achieved an 80% success rate on steps as high as 22.5 centimeters, using only time-of-flight sensors without visual inertial odometry. This proves the viability of lightweight exteroceptive sensing for rugged environments. Sim-to-real transfer remains a critical challenge in robotics research. Yu's team introduced depth transfer, an innovative method aligning simulated and real-world depth data for drones. Their approach nearly doubled obstacle avoidance success rates by employing domain randomization techniques to bridge the simulation-reality gap. This advancement significantly improves the practical deployment of learned policies in physical systems. Safety and robustness concerns have emerged as critical research priorities. Liyu's study revealed alarming vulnerabilities in vision and language navigation systems, demonstrating a 90% success rate for adversarial attacks that trick robots into harmful actions. These findings underscore the urgent need for comprehensive safety benchmarks in embodied artificial intelligence systems. Key findings across recent research highlight significant advancements. Quadrupedal robots now navigate extreme terrain with minimal sensor requirements. Adversarial prompts have been shown to pose genuine physical safety risks. Language models improve robotic grasp success rates by 41.43%. State-space models demonstrate superior performance in temporal reasoning tasks. Methodological innovations are driving robotics progress. Reinforcement learning with domain randomization enables robust policy training. Diffusion models handle multimodal scenarios in motion planning, though with high computational costs. Mamba state-space models effectively encode trajectory history. Researchers must balance semantic detail against real-time performance requirements, particularly for embedded systems. The seminal work by Plozza and colleagues focuses on robust locomotion for resource-constrained quadrupeds. Their key innovation fuses depth sensor data with proprioception using reinforcement learning. The system achieved 80% success on 22.5 centimeter steps. Open-sourced training code accelerates future research, proving lightweight sensing's viability for rugged environments. Liyu's groundbreaking paper exposes jailbreak attacks in vision and language navigation systems. Their three-tiered attack framework achieved 90% success in adversarial manipulation. These findings have critical implications for embodied artificial intelligence safety, strongly advocating for new safety benchmarks and robust defensive measures in autonomous systems. Zhou's MTIL architecture represents a breakthrough in temporal reasoning for robotic manipulation. By employing Mamba state-space models to encode full trajectory history, their approach overcomes limitations of Markovian policies. The system outperforms existing methods in sequential manipulation tasks, effectively bridging memory-augmented and Markovian approaches. Future research directions present both challenges and opportunities. Priorities include closing remaining sim-to-real gaps, developing adversarial training for embodied artificial intelligence, and optimizing models for edge devices. Establishing comprehensive ethical frameworks for safety evaluation will be crucial as autonomous systems become more prevalent. This presentation was synthesized using advanced artificial intelligence systems. Content generation utilized GPT DeepSeek models with text-to-speech synthesis via Deepgram. Visual elements were created using Google's image generation capabilities. While human experts reviewed the material for accuracy, potential oversights may exist. All references are provided for verification purposes. Stay updated on cutting-edge artificial intelligence and robotics research by subscribing to AI Frontiers. The YouTube channel provides regular updates on breakthrough developments and in-depth analysis of seminal papers. Subscribe now for the latest insights into the future of autonomous systems.